In this video, we're going to look at the sensible heat transfer equation for air. This is useful when trying to determine either of the three variables, BTUs, CFM, or delta T. When you know two of these values, you can determine the remaining missing value. We'll begin by calculating for the BTUs when given the CFM and temperatures of entering and leaving air. Remember, we're dealing with sensible heat only. That means there's no latent heat which involves a change of state, like moisture in the air condensing into water or condensate. All we're doing is changing the temperature of air while not removing any moisture. Looking at this heating hot water coil, we see that there is 2,000 cubic feet per minute of air flowing through this coil with a leaving temperature of 90 degrees Fahrenheit and the entering air at 55 degrees Fahrenheit. With this information, we can solve for how many BTUs are being supplied to the air. Step 1 is to subtract the entering air temperature of 55 degrees Fahrenheit from the leaving air temperature of 90 degrees Fahrenheit to arrive at temperature difference, or delta T. 90 degrees Fahrenheit minus 55 degrees Fahrenheit gives us 35 degrees delta T. Step 2 is to put all the known values into our formula and make the calculation. We have our formula of Q equals CFM times 1.08 times delta T. Now we enter our values, we get Q equals 2,000 times 1.8 times 35 equals 75,600 BTUs an hour. Now we can quickly explain where the value of 1.8 in the calculation is derived from. First, we have the weight of air at 0.075 pounds per cubic feet. Then we have the conversion of minutes into hours. And lastly, the specific heat of air at 0.24 BTUs per pound degree Fahrenheit. This is what that looks like. 0.075 pounds per cubic feet times 60 minutes an hour times 0.24 BTUs per pound degree Fahrenheit equals 1.08. With all these units, we can see which units of value remain by crossing out those that are eliminated in the formula, such as Q equals 2,000 cubic feet per minute times 0.075 pounds per cubic foot times 60 minutes an hour times 0.24 BTUs per pound per degree Fahrenheit times 35 degrees equals 75,600 BTUs per hour. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.